So, now we will delve deeper into what I call it as descriptive statistics. So far we have looked at what? We have been looking at only the basics, what are the kinds of statistics, what are the data, what are the types of data, and we have looked at what are the types of data, and then this is what it is. When you talk about variables, typically variables are of interest to us, because that is the one we will want to model. Okay. Parameter is something, depending upon the parameter the search space or things will change. Okay. Constants we do not worry about, we just fix it, right. So, variables are of interest to us, and variables themselves, as I said, are qualitative and quantitative. When you talk about qualitative, it becomes dichotomic or polynomial, that is two categories or multiple categories, and when you take about quantitative, discrete and continuous. I told you what practically continuous means, it is just that something with decimal points. Truly continuous we do not really measure, because the moment you measure you are actually restricting your bit size, right. So, that way truly continuous does not exist. Discrete is like you can think of it as integers, whereas continuous is with decimal points. Okay. So, now coming to this descriptive statistics, we are talking about how to present the data. Okay. So, descriptive statistics is all about presenting and summarizing. Okay. So, we have various ways of presenting, like using frequency distributions, graphical representations and summary statistics. We will start with frequency distributions. These are some things basics you should have learnt by now. Okay. We will quickly revise and go on. Okay. So, the simple thing is you are looking at how many times a data has repeated, you discretize. Okay. So, this is like tables, and what are you observing here, what kind of let us take a simple examples, what can you infer from this distribution table. Let us say I give you a sensor which measures pressure. Okay. What am I giving? I am giving a sensor which measures pressure. Okay. Let us say you are wearing it in your shoes. Okay. You are walking, you are running, you are jumping, right, you are doing all of this. Now you plot a frequency table. Okay. 10 bit ADC value from sensor. You know what is the 10 bit ADC value? 10 bit means 1024, 2 power 10, 1024. What do you observe from this? So, my 10 bit value is 1024, I have gotten 980 10,000 times. What does it tell you? What does it tell you about the sensor? It has hit the maximum, close to maximum value most of the times. Maybe the sensor is stagnant, saturated, right. So, simple tables like this can reveal you many information, much information. What else can I look from frequency distribution? Suppose I plot the frequency distribution of salary in an age group. What is the information I look for? Not just mean, median, mode, it is a frequency table. So, what am I saying? The distribution itself, the entire distribution itself. What is the lowest? Highest, what group people are in most of the time. This frequency table actually gives you a lot of information. You can derive actually a lot of information. This mean, median, mode is just summary of one number. Here I look at what is, if you want to look at how many are situated in this range, 90% of the range, how many people are there, right? Yes or no? This gives you like complete information. This is later on we will look like this is like a probability distribution function. We learn it later. This is like a distribution of the entire variable. Of course, you need enough measurements to come to conclusion. Be sure about it. We need enough measurements to make conclusions. If you have enough informations, this table reveals most of the information. okay. We can say how many are in the extremes, that tells you something of the age group, right. So, if you want to, if you start plotting the histogram or frequency distribution table, if you come up with the table and then say what is, how much a drug is effective or not effective, that will give you overall viewpoint rather than just single number. So, suppose if I say mean salary in this age, or mean salary in this age group, let us say 30 to 35 is 1.5 lakhs, does it convey much? Why? I do not know first how many people are there, okay, how many samples did they collect, okay, and on top of it I do not know whether there are outliers. So, few people getting 1000, 50,000 and one fellow getting 10 lakhs, what will happen? It will change, right. So, there are many things which will miss if you are summarizing using single number, whereas this distribution gives you a very holistic information. So, this is one way in which you present the data, provided if you have enough data, okay. All this table will become useless if you have lesser number. Why? Mean may be still useful, but this number will become useless, this graph will become very difficult to interpret. Why? If you have less data. But if observations are less, mean is also equally useless, right. But I say mean is slightly better compared to this, mean or some single number statistics is slightly better to compare to this inferring from whole plot. Why? See, if you give this kind of plot, this kind of table, you can take in lot of information, you can get lot of information like mean, like I can say what is the range, what is the 90%, 50%, lot of information. But when you want to extract lot of information, naturally you need lot of data, okay. The more information you want, the more observations you should have. It is a very fundamental theory. How many parameters you estimate, you should have enough data for that, right. So, frequency distribution is ideally preferred when you have more data, okay. So, these are graphical representations. So, you can see bar graphs, so where you could have one bar graph over the other. So, you can see here it is from a pharmacology data, okay, hypokinesia versus various parameters, okay. And similarly cumulative stereotype score, and then you have this parameters. So, what can we observe? So, what are these? What are these? These are outliers, we will come to calculate that, we will calculate how to do these outliers. In the bar chart itself you can represent outliers. So, what are we saying? Look, this is the average and there are some few data points extremely outside, that is what it is, okay. A single graph which will give you a representation of the whole data, comparatives as well as outliers. So, histogram, that is again a frequency versus variables of interest, okay. And then this is the polygon line graph which we all do, just a simple plot, okay. So, how do you, so this is like the steps for constructing a frequency distribution. How do you do a histogram given a data? How do you do a histogram? Typically you have to choose the number of classes, right. So, number of classes either you know a priori, which is not always the case. So, you make m equals to root n. So, the number of classes is equals to square root of n, that is a very good starting point for number of classes, and you have to determine the width, right. You have to break down the number of classes and then the width of the each class. The width of each class is given by max minus min by m. So, that way you uniformly distribute, or it becomes a uniformly tally the number of values and then prepare a table, that is straightforward. So, first 3 steps are the key. How many classes? M equals root n, and then the width is max minus min by m. Okay. So, this is a simple histogram. Okay. And then another common method is called frequency polygons. Okay. So, you mark the frequency on the vertical axis and the value of variable being measured on the horizontal axis as with the histogram. If the purpose of presenting is comparison with the other distributions, then the frequency polygon gives a good summary. It is an out, it is a, so this tells you, compared to this looks at tells you that this is close to what? Somewhat normal, in the sense both are equally distributed here, right. The center is, the mean is like the center, somewhat aligned. So, it gives you the outline of the frequency distribution. This frequency polygon is nothing but gives you the outline of the frequency distribution. Okay. And then this is ogives. Ogives are nothing but cumulative frequency distribution. So, so how frequencies increase, right. So, how many observations above, so ogive is used when one wants to determine how many observations lie above or below a certain value in a distribution, right. So, if you take, from this what can you infer? Is there extremes? Is it a skewed distribution or is it a pretty centered distribution? Skewed distribution, what will happen? If there are so much data in the left and so little in the right, it will get saturated in the right, it will not keep increasing. Okay. So, this tells you how to look at the skewness in the data, very simple ogives. Okay. So, these are increasing or cumulative distribution plots. We all know about pie chart, I do not need to tell you. Okay. Bar charts, pretty common.